All right, yeah. Hi, everyone. Thanks for coming today, and I'm going to talk to y'all a little bit about the research that we're doing. I'm Matt Hewitt. I'm a PhD student, or soon-to-be PhD student on this project. I'm here with Borderlands Research Institute. We're out of Sul Ross State University up in Alpine, Texas. With me here today is Nicole Dickin, waving her hand back there. She's going to be the master's student on this project, and Dr. Amanda Dutt. She's the postdoc on the project. She's the one that's keeping us moving forward and keeping us all in line and everything. So, like Krista mentioned a little bit ago, bears were extirpated from Texas by the mid-1900s and started coming back, in the 1980s, mid-1980s. There's reports of black bears in the national park, we assume at least coming back from the mountains in Mexico. I think it's a pretty strong assumption that that's where they're coming from, and they're moving northward. Within the past 5 years, and I guess you guys know better than anybody else, in the past 1 or 2 years, they've really kind of branched out, outside of the park, coming into the local communities and starting to engage with people. And that really presents an area of study that I think is very important. So with that, Borderlands Research Institute started a very long-term research project. It's going to be 5+ years of data collecting and research with some pretty broad overarching goals. There's things that we want to accomplish in the long term. One of which being understanding local population ecology. So things like birth rates, survivability, diets, broad-scale habitat preferences, things like that. Aid in understanding drivers of human-bear conflict. So, Borderlands won't be the ones doing on-ground, management or mitigation, but we can help supply Texas Parks and Wildlife with the best information available at the time. So, we study this specific population and, try and, inform Texas Parks and Wildlife the best we can. And also help inform management efforts. So even outside of human-bear, conflict situations, try and give the best information we can to make the best management decisions in the long term. And right now, so for the short term, things that we are doing, now, projects that have started and answers that we are trying to get at. Nicole is going to be starting her master's position here pretty soon, looking at seasonal movements and behavior of black bears. So how movements and behavior might change on a seasonal basis, from summer into fall into winter and back into spring. As well as some fine-scale habitat selection. So, kind of on an individual bear basis, right? Like, does it choose to go to this restaurant or this restaurant? Hopefully not literally, but this food source or this food source, right? Or this water source or this water source. So kind of on, a finer scale, smaller scale habitat selection. And then broadening up some of these questions that I would hopefully take into my PhD, some broader habitat modeling and population level modeling. So bears are coming back into Texas, they're moving northward, right? At least that's the idea. So potentially modeling, what that movement would look like moving northward, what habitats they would use to move northward, and what some of those corridors might look like. So to do that, we are capturing and collaring bears, right here in the Trans-Pecos and in South Brewster County, as well as some other places, but kind of, at the moment focusing right here locally. We are using culvert traps to catch bears. There's, one out front if you feel like going around and taking a look at it. It is a very safe and reliable method for capturing bears. It is used, all over the world for capturing, every species of bear that there is. Humans can't get hurt, if the bear's in the trap, and other bears can't hurt that bear, the bear can't hurt, people on the outside, right? So it's a very safe way of catching and containing the bear. And we also use, so this is a satellite trap transmitter. It's a, satellite transmitter that whenever this little plunger pops out, it sends us an email and a text message to, a variety of people alerting us that trap just went off. A very useful tool, especially out here in Western Texas where it does get incredibly hot. You don't want to leave a bear trapped in a metal oven for 6 hours in a day, right? So we're trying to reduce our response time as much as we can and get to that bear, so it is safe. So once we get to the bear, we are able to chemically immobilize it and pull it out of the trap and get it down on the ground. And we're taking every precaution we can to make sure this bear is safe and stress-free. Obviously it is under anesthesia, so it's not awake by any means. But just trying to reduce the amount of stress that this bear goes under during the time that we have it in hand. We also have some electronics hooked up to it to monitor heart rate, breath rate, oxygen saturation in the blood, so all of these vital signs to ensure us that this bear is doing just fine. And while we have the bear in hand, we want this to be the only time that we ever have to handle this bear. As researchers, we are trying to maintain this population as wild as they can possibly be. So we're trying not to alter their natural behavior, right? So we don't want to have to mess with them more than we have to. So we try and get every sample we can while we have them in hand. So we're collecting things like hair, blood, tissue, fecal samples, to do multiple analysis with later on in the future, as well as attaching a tracking collar to them, which I can pass around and you guys can look at. I do need this back, this is very expensive, but feel free to look at it. This isn't the exact model we're putting on the bears, but it is very, very similar. And so once we have all this stuff on the bear, we also do put ear tags. So if you ever see an ear tagged bear, your Texas Parks and Wildlife representative would love to know. We are also putting ear tags in them, as well as a pit tag, the same sort of thing that your dog or cat would get at the vet's office. And then, once we're done handling the bear, we do administer a reversal agent, which will bring the bear out from under anesthesia. Usually takes about 10 to 20 minutes to come out from under anesthesia, and then it stands up and walks off of its own accord and goes about its business. So a little bit about these collars. They're made by a company called Vectronic. They are kind of the gold standard for collecting movement data on wild animals. This company makes collars, here to the ground to go on elephants, and as small as go on little tiny baby deer, right, fawns. So very experienced company, and like I said, kind of the gold standard for collecting location data for animals. A little bit about our collars specifically. These ones are satellite capable, meaning that they will take a GPS point and upload it to a web service that we can then see, and in almost real time see where this bear is and what habitats it is using. They also emit a VHF signal, which stands for very high frequency. It's a type of radio signal that we can track in actual real time. If we're out on the ground trying to find the bear, that is the method that we would use. We have them programmed to take a GPS location every 2 hours. So taking 12 points a day, and it'll upload to that web service twice a day. So, like I said, not entirely real time, but almost real time with the GPS. And these are the type of collar that do fall off. This is not a permanent fixture on the animal. It's not going to die with this collar. It will fall off. And we try to fit the collar to the bear, right? Bears can range from yay big to yay big. Well, not that big, but very small to a very large bear. So it's not necessarily one size fit all. So we have different band sizes as well as different battery sizes, and the battery size is what controls that drop-off mechanism. So we try and match the smaller battery size to a smaller bear. The smaller bears are the ones that are capable of putting on a lot of weight very quickly and growing very quickly. So we don't want to fix something a certain size that fits them when they're 3, that might not fit them when they're 6. So we put a collar that will drop off sooner on smaller bears and collars that will last longer on larger bears. So here's just some pictures. The top right is us researchers using that VHF receiver to listen for the signal that this collar gives off. And then this bottom picture here is what that GPS data looks like on the web service. So for some perspective here, this is Big Bend National Park. We are probably that white dot or something here in Study Butte, and that's the ranch and Black Gap, and this is Alpine. So capable of very, very big movements. Like Krista said, this project started this past summer, so we've only got about 4 months worth of data on 10 bears, 9 male, 1 female. So we're still collecting data and don't have a whole lot to go off of at the moment. But what we can tell you is that they are capable of very, very big movements. Certainly more than I ever thought they would be moving out here. So yeah, some examples here: 128 miles in 30 days, and that's not walking, in a circle. That's a straight line distance. So capable of moving very quickly, very far. And this BB-M08, the one that got moved from the ghost town over here, like Krista said, we moved him over to Black Gap Wildlife Management Area, and he was able to walk the 35 miles back to the ranch headquarters in just under a week. And showing, reiterating that they are very, very food motivated. He was willing to do that to get back to his favorite food source. Another just kind of fun visual here. There's a bear that we caught down in Black Gap that wandered onto some private properties elsewhere and found himself some deer feeders and has been there for 2 months. These points represent 2 months worth of time, and he hasn't left. So he found something he likes, and he's going to stick to it. So here I'm going to roll through some home ranges of the bears that we have collared so far. So this little collection of points down here is every single point GPS location that a caller has sent from us or to us of this particular bear. So that represents one bear. And it's kind of hard to see, and it's really busy. So I'm just going to throw a polygon around the outside of it and then roll through some multiple bears here. So this one did venture down into the national park, into the Chisos Basin, and up into the ranch area. So yeah, like I was saying, capable of moving very, very far. Probably blocking the view for a lot of y'all back there, but yeah, very dramatic movements. This one made us international bear researchers. I was very proud of that. And made a little trip across the border and then came back. And then some, find a hillside they like and never leave. So they're very different. And then, this is our one female, which oddly enough has made the biggest movements. And one up closer to Alpine. So next steps with the project is we do have another 20 collars in the mail that we're going to be getting in and be continuing our collaring efforts into the spring and summer, as well as continue to help design and conduct studies that will help inform bear management into the future. So like I said, this is going to be a longer term project, 5+ years. There's going to be, Nicole and myself and probably other students in the future. So coming up with more questions that will help inform Texas Parks and Wildlife to, manage the species the best that they can. And possibly leaning towards some different techniques. Collars are very expensive, like I mentioned, and there are other methods out there for monitoring populations, such as hair snares or trail cameras. Some different methods that we might test out in the future. Thank you to Texas Parks and Wildlife for putting this thing on and the venue for hosting us here, and I'd love to take any questions if anyone has any questions.